So hello, so this is Yashaswini. So today we are going to talk about chemical bonding. Okay, so chemical bonding between, of course, two atoms. So before going into the chemical bonding, let's first understand what does an atom has. Okay, so we have an atom. Okay, so atom as nucleus. Okay, so it has a nucleus. In nucleus we have protons and neutrons. Okay, and surrounding outside of the nucleus we have electrons. Okay, so these electrons are orbiting around the nucleus. So this is basically a nucleus, and these electrons are orbiting around the nucleus. Now, how are these electrons arranged? So you won't have, atom will never have one hydrogen atom has one electron. So sometimes there may be many electrons, as in when the atomic number increases, the electron number also increases. So how are these electrons arranged? Okay, so basically these electrons are orbiting around the nucleus in shells. They are actually orbiting around the nucleus in what is called as shells. So we have a nucleus here. Okay, so we have a nucleus. Okay, so this is going to be the nucleus. So around it there are shells. So this is the first shell, which is the closest to the nucleus. So this is going to be called as n equal to 1, that is first shell. Then we have another shell. Okay, so this is going to be the second shell. It's going to be called as n equal to 2. Okay, then we have another shell. There are many shells, it goes on and on. So this is going to be the third shell. Okay, so this is going to be n equal to 3. So the shell which is closest to the nucleus is numbered as 1, then the next shell is numbered as 2, next shell is numbered as 3. So basically n gives shell number. Okay, so now this shell number has one orbital. Okay, these shells will have orbitals. Okay, so this will have orbitals. So orbitals are named as S, P, D and F and so on. So this first shell will have only one S orbital. Okay, the second shell will have 2 S and 2 P orbitals. So second shell will have 2 orbitals, and the third shell will have 3 S, 3 P and 3 D. Fourth cell will also have again 4s, 4p and 4d and 4f, but right now we are not going to talk about it. So now here this s orbital can accommodate 2 electrons. P orbital can accommodate actually 6 electrons. D orbital can accommodate 10 electrons, and okay, F orbital it can accommodate 14 electrons. So now this shell number 1, first shell, has only one s orbital, so it can accommodate 2 electrons. The second shell, it has 2s and 2p, so s can accommodate 2, it is the maximum number, and p can accommodate 6. So the second shell can accommodate total 8 electrons. Okay, the first shell can accommodate 2 electrons. Similarly, when you come to third shell, it can accommodate s orbital can accommodate 2 electrons, p orbital accommodates 6 electrons, and d orbital accommodates 10 electrons. So the third shell can accommodate completely 18 electrons. So this is how the filling takes place. The first cell can take 2, second cell 8, and the third shell can take 18 electrons. So now the question is, which orbital gets filled first? So you just don't go start filling 1s, 2s, 3s. So for that there is a rule. So just let me write all these orbitals one by one. So I have 1 s, I have 2 s and 2p here, and 3 s, 3p and 3d here, and then coming to the fourth shell I'm going to write 4s, 4p, 4d and 4f. Okay, so now how are the shells orbitals filled in an atom? So first what are you going to do, you're going to draw an arrow like this. Okay, then you're going to write the next arrow which is going to cut the first orbital of the next row. So it's going to come like this. Next arrow, it is going to cut the first orbital of the third row. So it is going to come like this. Okay, so next arrow, it's going to come like this. Okay, so now we are going to follow the arrow. So the arrow which is passing through first is 1s. So 1s will get filled first. Next it's going to be 2s. So 2s will get filled next. Next it is actually going to be 2p. The next orbital which is going to fill is 3s. Next it is going to be 3p and 4s. So it goes so on and so forth. So to explain the filling atomic configuration, this is actually called as electronic configuration of an atom. Okay, so how are all the electrons arranged in an atomic orbitals? So this is called as electronic configuration of an atom. Okay, so now let me take an example and I'm going to show you how it is, what is the electronic configuration of an atom. So let me take first helium. I'm going to take some noble gases. I'm going to take helium as 2 electrons. Its atomic number is 2, so 2 protons and 2 electrons. So what is going to happen now? First this one is getting filled. So helium electronic configuration is going to be 1s2. Okay, so nextly we have neon. Okay, neon, it is going to be 10. Its atomic number is 10. So it has 10 protons and 10 electrons. So you need to fill 10 electrons in these orbitals. So first which one is going to get filled? First 1s will get filled. So 1s will have 2 electrons. It can accommodate 2 electrons. The next one which is going to get filled is 2s. So I'm going to write 2s. So how much can s fill? It can accommodate only 2 electrons maximum. So I'm going to write 2. So now how many electrons are filled? 2 plus 2, 4. Remaining 6 are there. So I need to go to the next orbital. So next orbital, it is going to be 2p. Okay. So what is the maximum electrons which p can fill? It is going to be 6. So now how many electrons I have accommodated? 2 plus 2 plus 6, it's going to be 10. So this is what is neon. Okay, so this is what it is. So this is how an electrons in an atom are actually filled.